This video is intended to quickly illustrate ProbMetab package features following the study case example. In order to summarize the analysis flux, we only highlight the most time-consuming steps. If one wants, detailed information can be found in the study case supplementary file and package function manual pages. To have a quick dynamic visualization of putative compound connections found in our sample, we export a graph with associated information to Cityscape Web. The dynamic visualization with our web server allows the inspection of the overlapped network of reactions and connections without installing and opening other software. The supporting information help the user to identify interesting relations associated with significant intensity mean changes. The main product of this analysis flux is a matrix with the probability of each mass to compound attribution. The user can optionally export a TML table with chromatogram peaks and link the ranking, database, mean difference and peak shape information. This table can be visualized locally with a web browser, and allows the ease sharing through web. Extending the idea of information overlay, one can export the ranking to Cityscape desktop. We also can use graph formatting properties to overlay information of different sources, as differential correlation. This idea can be applied to different sources of information, which can be exported as node or edge properties. Node and edge attribute lists are also important, to allow individual search by Cityscape built-in filter tool. Cityscape is a rich network exploratory environment, and we make use of standard layout and filter tools. The data sent from R and visualized in data panel allow the integration of information to the network context, providing means to improve the metabolite identity selection. To search for pathways and reactions of interest, we have to load the node and edge attribute lists. Our R functions allow to export the putative metabolite to pathway association list, optionally filtered by organism phylogeny. We can search and highlight a specific pathway, navigating the information associated in the data panel. Selecting all edges incident on a given node is possible to see the possible identities associated with this connection. Generally, the number of identities given by mass search is reduced with the overlay of the correlation. Its further association with the highly represented pathways and probability ranking can lead to a correct metabolite identity. Once we fix a target pathway, we can draw the KEGG pathway map through R to investigate the metabolite context. This is important because some metabolites may be absent for analytical limitations, such as extraction buffer exclusion, or lack of ionization. With this, it is also possible to dynamically search information, as well as to edit and save for later inference.